Dear friends, as you may know, Maths Aspirants is a collective of mathematics students initiated by myself in 2017, and we used to organize several online programs to help the students who prepare for different national level competitive examinations, PG and PhD entrances. Today, we are organizing an orientation session for IIT JAM Mathematical Statistics as well ISI MStat entrance exam. Today we blessed to have Miss Elizabath Joy with us. She is a member of our group since her BSc time itself. She is from Kerala. She did her BSc in Mathematics and MSc in Statistics and now pursuing PhD at ISI Kolkata. She qualified all national level tests like GATE, NET examination, PhD entrance of ISI with good ranks. I'm sure that today's session will be really helpful to all those who wish to pursue a career in statistics. So I welcome everyone to this program. Welcome, Elizabeth.
Thank you, sir. So I can start, right? So first of all, I would like to thank Vinod sir for inviting me for this program. I am so happy to be a part of this community. So today's session will be an orientation session for the IIT JAM and ISI MStat entrance exams. So I will be explaining the syllabus and the exam pattern of these two exams initially. So about the ISI MStat entrance exam, the syllabus, I hope you can see my screen. In the syllabus, you can see the portions are from mathematics and then statistics. So very less portions are included from the statistics topic. Okay. So compared to all other exams like the IIT JAM exams, there are different topics like covering almost all area of statistics. But in ISI entrance exam, they are more focusing on the probability, random variable theories, the distribution related topics, then inference topic, the estimation and testing, then design of experiments. Only these three papers are coming under the statistics paper. Then about the mathematics paper, it contains the real analysis mainly, then the linear algebra topic. Okay. So then complex analysis related, some topics are from the complex analysis related area. The syllabus is actually too short as compared to all the other competitive exams in statistics, the ISI entrance exam. Okay. So for the IIT JAM mathematical statistics examination, so the syllabus is this. It consists of, from mathematics, it contains a sequence and series of real numbers topics. So in detail, the syllabus is given. So this is the latest syllabus of 2026 JAM exam. Then it contains the differential calculus. So of one variable, two variable, then integral calculus. Then from linear algebra topics, metrics and determinants topics is there. Then from statistics, it contains the descriptive statistics related topics, then probability, univariate distributions, multivariate distributions, then limit theorems, that the convergence area in statistics, like the convergence in probability distribution, those kind of things. Then sampling distributions. Then from inference, the estimation, theory of estimation, testing of hypothesis. Then non-parametric methods and stochastic process. So this will cover the syllabus of IIT JAM Mathematical Statistics examination. Okay. So about the exam pattern, the IIT JAM exam consists of total of 60 questions. So it is divided into 3 sessions like section A, B, and C. In section A, it contains 30 multiple choice questions. Okay, so the first 10 questions will be of 1 mark each, and the next 20 questions will be of 2 marks each. In section B, there is a total of 10 multiple select questions. That is, there will be more than one correct option for each question. Okay, so that is the idea. Then for section 3, it contains 20 numerical answer type questions. Okay, this pattern is same as the other IIT JAM examinations actually. Then for this exam, the section A has negative marking also. For the multiple select and the numerical answer type, there is no negative marking. And also for the multiple select type, there is no partial marking as well. So if you select every correct answer, then only you get the mark for that particular question. So that is about the exam pattern for the IIT JAM Mathematical Statistics Examination. Then about the ISI MStat entrance examination, the exam is divided into 2 papers. So the exam will be happening in a single day, 1 paper in the morning session and 1 paper in the evening session. So the first paper is PSA, which contains the multiple choice questions from the syllabus mentioned earlier. Okay, so in that near about 30 questions will be there. About the marking, actually I am not sure about. The question paper is not exactly the question paper of this. I mean, in the website, you can find the question papers for the last few years, and that is mentioned as sample question papers, which means the pattern will be same, but not exactly the same question papers that happened in the last years. Okay, so I am saying that because last year when I gave the JRF entrance exam, my question paper, so whatever the question paper given in the site as the question paper for the last year exam, that is different from the actual question paper. So which means you can see, you can get a idea about the pattern of the questions that they will ask from the sample question papers. The exact question papers you cannot find from the website. Okay, so this is about the PSA, the morning session exam. It will be containing multiple choice questions only. Then in the afternoon session, you have to give the descriptive exam. Okay, so the question pattern will be like this. So to prove something, then to show that something, it will be a descriptive kind of examination. So the number of questions may vary depending on the year. In general, maybe some 10 questions. All the questions will be of having equal mark. Most of the situations that is happening here. Okay, so that is all about the syllabus and the exam pattern of this JAM exam and the ISI MStat entrance exam. So now I will be dealing with some previous year question papers from this ISI entrance exam and this JAM exam. I have taken the questions from the probability and distribution related topics. So we can start the PYQ discussion. So before that, I request you all to participate actively in the session. So let's start. Okay. So the first question, we can go. First question, let alpha greater than 0. Then find the value of limit n tends to infinity, gamma to alpha by n divided by gamma alpha by n the whole square, integral 0 to 1 x raised to alpha by n plus 1, 1 minus x raised to alpha by n minus 1 dx. So this is a basic question which you can answer based on the gamma integral properties and the beta based on the gamma function properties and the beta integral properties. Okay, so I think you can all try how to solve this problem. So we can wait for some time for that. You can just try how to approach this question. And any queries you can ask me directly by unmuting your mic, or you can post your comments in the chat box also. Okay. So first thing is you have to identify these integrals. So here limit n tends to infinity is there, which means after evaluating this function, you have to apply this condition limit n tends to infinity. So for initially, you don't have to think about this limit. First, you have to find out this integral, then simplify this expression, and then we can apply the limit. So on seeing this integral, you should be able to identify this as a beta integral, the first kind beta distribution property. I hope you all know. So what is the property? So beta integral is integral 0 to 1 x raised to alpha minus 1, 1 minus x raised to beta minus 1 dx. So this will be equal to beta alpha beta. Okay, and this beta alpha beta, we have beta alpha beta is equal to gamma alpha gamma beta divided by gamma alpha plus beta. Okay, so for this question, you have to identify what is the value of alpha, what is the value of beta, then substitute in this beta function, then you can evaluate this integral. Okay, so what is the value of alpha here? Alpha is equal to, if you compare the the term x should have the power alpha minus 1. Okay, so first of all, you have to write this x raised to alpha by n plus 1 in this form, something minus 1, and that something will give you the alpha for this result. Okay, so alpha by n plus 1 can be written as alpha by n plus 2 minus 1. Okay, so here the alpha will be equal to okay, so let me just change this alpha and beta as some PQ, otherwise we may get some confusion. So I am just writing this as x raised to p minus 1, 1 minus x raised to q minus 1. Then this is beta PQ. Okay, then beta PQ is defined as gamma P gamma Q divided by gamma P plus Q. Okay, so what will be the value of P here? So we have to find the value of P and Q from this relation. So what will be the value of P here for this problem? Okay, so that will be alpha by n plus 2. Then what about Q? Q will be equal to, that is already in the standard form, Q minus 1 form. So Q will be equal to alpha divided by n. So you can evaluate this beta function, beta PQ, and that will be beta alpha by 2 plus 2 comma alpha divided by n. So what will be the value? This is equal to gamma alpha by 2 plus, sorry, alpha by n plus 2, this is n, gamma alpha by n divided by gamma alpha by n plus 2 plus alpha by n. And you all know the property of gamma integral. The gamma integral is gamma n is equal to n minus 1 factorial, and you should be aware of the other forms. We can write this n minus factorial. So n minus factorial, you know, that is equal to n minus 1 into n minus 2 factorial. That is, again, we can write in terms of gamma function as n minus 1 into, then you know gamma n minus 1 will be equal to, so whatever is there inside the gamma function, you have to just take one subtraction. Okay, so gamma n means n minus 1 factorial. So gamma n minus 1 means n minus 1 minus 1 factorial. So that will be equal to n minus 2 factorial. So instead of this n minus 2 factorial, you can substitute this as gamma n minus 1. So in this way, based on the question, based on the requirement, we should be able to convert this gamma into these different forms. Okay, so what is the value of this beta alpha by n plus 2 alpha by n? You can evaluate this gammas, and then you can substitute, you can simplify. So how to solve? So gamma alpha by n plus 2, gamma alpha by n in the denominator. So here you can see we have to substitute this beta instead of this integral here. So there is already a gamma 2 alpha by n, gamma alpha by n the whole square, the denominator. Okay, so when you substitute this, 1 gamma alpha by n, it will get cancelled with this one. So we have to think about one more alpha, gamma alpha by n in the denominator, then one gamma 2 alpha by n in the numerator. Okay, so we can simplify this for getting this form. Okay, so this will be equal to gamma alpha by n plus 2 will be equal to alpha by n plus 1 into alpha by n into gamma alpha by n. This first term, and this is gamma alpha by n. I am writing that as gamma alpha by n. Then in the denominator, this is alpha by n plus alpha by n, that is 2 alpha by n. So that is actually gamma 2 alpha by n plus 2, and that can be written as 2 alpha by n plus 1 factorial it will be. So that again can be written as that into gamma 2 alpha by n plus 1. Then this gamma 2 alpha by n plus 1 can be written as 2 alpha by n plus 1 into 2 alpha by n into gamma 2 alpha by n. Okay. So instead of this denominator, you can substitute this as 2 alpha by n plus 1 into 2 alpha by n into gamma 2 alpha by n. Okay. Now you can just substitute this beta value. I mean, this integral value we got as this beta alpha by n plus 2 alpha by n, and that value is same as this. Okay. So now the limit will be limit n tends to infinity, gamma 2 alpha by n divided by gamma alpha by n the whole square into alpha by n plus 1 into alpha by n gamma alpha by n, again gamma alpha by n divided by 2 alpha by n plus 1 into 2 alpha by n gamma 2 alpha by n. Okay, so the numerator and from the numerator and denominator, these terms, this gamma terms will get cancelled out. So the resultant equation will become alpha by n plus 1 divided by so here an alpha by n is there, here also an alpha by n is there, so that also we can cancel out. So 2 times 2 alpha by n plus 1. Okay, so limit is there, so limit n tends to infinity. So as n tends to infinity, alpha by n is alpha by infinity, that term tends to 0. Then 2 alpha by n, so when n tends to infinity, this term also tends to 0. So the limit will become, so this 1 by, this 2 is there, the denominator, then this will be contributing 1 and this will be contributing 1. So the limit will become 1 divided by 2. Okay. So this is just simply the application of gamma integral and the gamma function and the beta integral properties. I hope this question is clear to all. So if you have any doubt in any step, you can ask me. Okay. Otherwise, we can move to the next question. So any doubts? Okay, so let's move to the next question. The question is, let A and B be two even such that P of A is equal to 1 by 2, P of B is equal to 4 by 9, P of A given B is equal to 3 divided by 4. Let X be the random variable which takes the value 1 if A occurs and 0 otherwise. Similarly, Y is a random variable which takes the value 1 if B occurs and 0 otherwise. So consider the following statements. Expectation of xy is equal to 1 by 3, probability of xy equal to x square y square equal to 1. So the options are like which of these two statements are true, or which are true and which are false. Okay. So before going to this question, I would like to add a note on this indicator random variable. Here, the random variable x and b are indicator random variable that is shows whether the event A occurred or not and the event B occurred or not. Okay. So about the indicator random variable, I will give you the definition first. Let consider x. Let x be let x be an indicator random variable that is x is equal to IA. We can write it as IA. IA means it indicates whether the event. So for every event, the two possibilities are either it can occur or it cannot occur. Okay. So x equal to IA means it indicates whether A occurred or not. If A occur, then the value of x will be equal to 1. If A is not occurring, then the value of x will be equal to 0. So x can take only two values. Okay, So the x will be defined as x is equal to IA, that is equal to 1 if A happens, and that is equal to 0 if A complement happens. We can say A doesn't happen. Okay. So then here the expectation of x will be equal to probability of A. That is probability of that event. This will be the probability. Why? Here x is a discrete random variable, and we know what is the expectation of a discrete random variable. It is summation over x p of x. So x can take two values, 1 and 0, and 1 if A happens. So 1 into A happens means we have to multiply the probability of A plus the next term will be 0 into probability of A complement. So that will give you probability of A. So for an indicator random variable, the expectation will be same as the probability of that event about which the random variable is defined. Okay. Then for the variance of x, that will be equal to probability of A into probability of A complement. This also you can simplify using the expectation of x square definition and then substituting this expectation of x. Okay, so I think based on this, you can find out the probability, find out this expectation of x into y. So how to find out the expectation? So to find the expectation of x, so x and y are discrete, so x into y, when you multiply, that will also give you different discrete values. So you have to find the different values of x into y. X and y are random variables, so x into y is also a random variable. So find the values of x into y, then corresponding probabilities, then you have to find the expectation using the definition. Okay. So here, what are the possible values of x into y? X can take the values 0 and 1, y can take the values 0 and 1. Okay. So if you cross multiply, x is equal to 0, y is equal to 0 is a combination. So 0, 0, that will give you x into y as 0. Okay. Then 0 into 1. If you consider 0 into 1 will give you x into y as 0. Then if you consider 1 into 0, 1, 0 will give you the value as 0. If you consider 1 into 1, that will give you the value of x into y as 1. Okay. So x into y can take only two different values. Xy takes 0 and 1. So probability of xy, probability of xy means probability of getting 0 and probability of getting 1. So what will be the probability of x into y is equal to 0? Or you can, so here x into y can take only 0 and 1. So either you can find the probability of 0, 0, 0, 1, 1, 0, and 1, 0. How to find 0? So both these two events are, you can consider these two as independent events. So there is no mentioning about the dependency. So you can find 0, 0 means you have to multiply the probability of x equal to 0 into probability of y equal to 0. Then probability of x equal to 0 into probability of y equal to 1. Then so in that way you can multiply and then take these probabilities. Okay. So one other method is here x into y is also 0 and 1. So x into y can be also taken as an indicator random variable since it is taking the value 0 and 1. So it's expectation value. So whenever a random variable x takes only two values, that is 0 and 1, then its expectation will be same as the probability of that event. Okay. So here based on this definition, we can see probability of expectation of xy will be equal to probability of xy is equal to 1. Okay. So that will be equal to probability of x into y equal to 1, which means when it happens, x and y should be equal to 1. Sorry, x into y equal to 1. That will happen only when x and y both are equal to 1. So that is equal to probability of A intersection B. Okay, that is A should happen only then x can take value 1. B should happen only then y can take value 1. So when x equal to 1 and y equal to 1, then only x into y can take the value 1. So the probability will be equal to probability of A intersection B, and that will be equal to 1 divided by 3. Okay, it is already given A given B is equal to 3 by 4. So A given probability of A given B is equal to probability of A intersection B divided by probability of B using the conditional probability definition. So from this, you can find out the probability of A intersection B as probability of A given B into probability of B. Okay. So either you can check in this way, or you can find out. So since the random variable is taking only 0 and 1, whatever be the probability, this probability will be equal to the sum of these three probabilities. Okay. When x equal to 0, y equal to 0, x equal to 0, y equal to 1, x equal to 1, y equal to 0. So you have to find these three probabilities, and then you have to add this. So, but when you take the expectation of x into y, say x into y is equal to some z, if you hold, then z can take the value 0 and 1. So whatever be the probability of 0, that is not going to affect the expectation, because 0 into that probability will come. Okay, so that term will get cancelled. So you have to think about the one part only, and you have to find out the probability of x into y equal to 1 only. So that is why this expectation will become like this. Expectation of xy is equal to probability of x into y is equal to 1 only. That is 1 into that time will come. So 1 into probability of xy equal to 1 is equal to probability of xy equal to 1. Then that will be equal to x into y equal to 1, means both x and y should be equal to 1. So only in that case x into y equal to 1 will occur. So that equal to probability of a and b should happen. Okay, only if a happen, x equal to 1, only if b happen, y equal to 1. So probability of a intersection b, that is equal to 1 divided by 3. That you can find out from this relation. You can just substitute and then find out this a intersection b value by multiplying probability of a given b and probability of b. So the first part, expectation of x into y equal to 1 by 3, that statement is true. Okay. So again, one more thing. So whenever a random variable is taking the value 0 and 1, you know, x is taking the value 0 and 1. So what is the possible values of x square? That is again 0 and 1. Okay. So probability of x equal to 1, probability of x equal to x will be always equal to x square. So that also you have to. So in case of Bernoulli trials and all, this result will hold. Okay. So there are many problems to apply this idea. When x equal to 0, x will take the value 0 and 1. X square can also take the value 0 and 1 only. Okay. So probability of x into y. So if you consider x into y, x is equal to x square. Okay. X is identically distributed with x square. Both x and x square are identically distributed. So x into y, you can write as x square into y square. Okay, so that implies probability of x into y equal to x square into y square will be equal to 1. So I hope this question is clear to you all, the explanation. So here the second option will also be true. So the correct answer for this question will be both 1 and 2 are correct. So any doubt in this question? Shall I
Ma'am,
explain?
can you tell me the x square and y square section again?
Yes, yes,
Can you
I can.
explain the
So
x square and y square?
yes, yes. So here, what I am saying is, say, x can take the values 0 and 1. Okay. So what are the possible cases of x into y? X into y have the different combinations that I already written here. X can take 0, y can take 0. Then x can take, these are the different combinations. Okay. X and y can take. So x equal to 0, y equal to 1. X equal to 1, y equal to 0. X equal to 1, y equal to 1. Okay, so these are the XY pairs actually, the different combinations of XY pairs. Then based on these XY pairs, we can find the value of X into Y. So when X equal to 0, Y equal to 0, X into Y will be equal to 0 into 0, that is 0. Then here again 0 into 1, that is 0. 1 into 0, that is 0. 1 into 1, that is 1. Okay, so X into Y can take the values 0 in these three cases. So the probability of X into Y equal to 0, how it will become? The sum of these three cases. Okay. Then the other value possible for x into y is this 1. Okay. And the probability is probability of x equal to 1 and y equal to 1. So that probability will give you the probability of x into y equal to 1. Okay. So that is the different possible values of x into y. Then what I said is, if x has this form, I mean this x equal to 0, 1, this Bernoulli trial form, then what is x square? When x equal to 0, x square will be equal to what? That will be equal to 0, right? When x equal to 1, then x square will be equal to 1. You understood this part?
Yes.
Then similar for the case of y. Y also take the two values 0 and 1. So when y equal to 0, that will give you y square again equal to 0. Then y equal to 1 will give you y square is equal to 1. Okay. So x into y equal to, so x into y can take two different values 0 and 1. Okay. So what I am saying is when the random variable x is having this form, the like x will take only the value 0 and 1, then x is identically distributed to x square. That is, the distribution of x and the x square will be same. Okay. So in general, if you take any power, x is identically distributed to x cube, x is identically distributed to x to the power 4. So in any form, if you consider, so there may be sometimes there will be questions like what is expectation of x raised to some power. Okay, so that time you can consider that the x to the power 4 is identically distributed to x. So the expectation of x will give you the expectation of x raised to 4 value also. This is the idea. So whenever x into y equal to 0, then x square into y square will also equal to 0. Okay, so only whenever x into y equal to 0, then only x square into y square equal to 0. Similarly, when x into y is equal to 1, then only x square into y square is equal to 1. Okay, that is the idea.
Okay, ma'am.
So x into y equal to x square into y square always, because x and x square are taking the same values, y and so identical distribution, right? Y and y square are taking the same values. That is the idea. So this is always true. What x into y will be equal to x square into y square. This is always true. Like when x equal to 0 and y equal to 1, what is x into y? That is equal to 0 into 1, which is equal to 0. Then in that case, what is x square into y square? That is again equal to 0 into 1. X equal to 0 will give you x square 0, y equal to 1 give you y square 1. So 0 into 1, that is again equal to 0. So this is a sure case, like x into y always equal to x square into y square. This is sure case. Okay. So the probability of a sure event, that is equal to 1. So that is the idea. I hope now it is clear.
Yes, ma'am.
Okay. So any doubts about this question in any other part? Okay, 1 minute. Let me just. So any other doubts in this question?
No, ma'am.
Okay, fine. So if anyone having any doubts, you can ask me in between. Okay, if you are not confident to unmute the mic and ask, you can just type in the chat. I am just looking into the chat also. So no problem. At any point, any doubt you can ask. Okay. So let's move to the next question. Suppose x1, x2 follow a bivariate normal distribution with the expectation of x1 is equal to expectation of x2 is equal to 0. Variance of x1 is equal to variance of x2 is equal to 1. Then the covariance between x1 and x2 is equal to rho for some 0 less than or equal to rho less than or equal to 1. Then expected value of x1 square into x2 square. So this is what we have to find out. So how to solve this problem? Any idea? So I can mention some, so we can do this problem in different ways. So first of all, I will mention some results related to this bivariate normal distribution of connecting this correlation coefficient and the expectation variance. Okay. So the first relation is if xy, ordered pair xy, XY follows a bivariate normal distribution with 0, 0, 1, 1 row. This is the general definition of a standard bivariate, like mean 0 and variance 1 and covariance 10 definition. Then the correlation, between x square and y square is rho square. So before that, let me explain one more thing. This is covariance between x1 and x2. So how to define the covariance between two variables x1 and x2? That is equal to expectation of x1, x2 minus expectation of x1 into expectation of x2. Okay. So this will be equal to, this term is equal to 0, this term is equal to 0, then expectation of x1 into x2. So this will give you expectation of x1 into x2, and that is equal to this is equal to this covariance, right? Expectation of x1, x2 equal to covariance of x1, x2, and that is given as rho. Okay. Then what is the correlation coefficient? So correlation coefficient between x1 and x2 is equal to covariance between x1 comma x2 divided by standard deviation of x1 into standard deviation of x2. Okay, so here the variance is given as 1. So the standard deviations will be also equal to 1. So the covariance and correlations will be same. So even though it is mentioned as covariance is equal to rho, we can treat this as correlation. Okay, so that thing you should remember, because in the general definition, this rho we are considering is the correlation. Here in this question, covariance is given as rho. So the correlation in this case will be also equal to rho. Okay, this idea you should remember. Okay. So here, then the correlation between x square and y square is rho square. So this is a relation, and from this relation, what you can do, you have to find the expectation of x1 square into x2 square. Okay, so you can just use the definition of correlation between x square and y square based on this same idea, and then you can find out this expectation of x square into expectation of x square into x2 square value. So I think you can all try and then find out, let me know the answer what you are getting. So just try. So what I am saying is just give the definition of, this is the result. You can apply this result, the correlation between x square and y square. So just expand correlation between x square and y square. Sorry, here it is x1 and x2. So we can go with x1 and x2. So x1 square and x2 square, that will be equal to covariance between x1 square, x2 square divided by standard deviation of x1 square into standard deviation of x2 square. So this is a definition of correlation. Now we have to find the covariance between x1 square and x2 square. So what is covariance between x1 square and x2 square? That is equal to, we can apply this definition. So that is equal to expectation of x1 square into x2 square minus expectation of x1 square into expectation of x2 square. So you can simplify this value. So this is, for the time being, we don't know. We have to find that value actually. Okay, so we can take it as this this itself, then substitute expectation of x1 square, expectation of x2 square. And then this is equal to rho square we have. Okay. This correlation between x1 square and x2 square is equal to rho square based on this result. We are applying this result. So covariance we got as this, and from this, what is expectation of x1 square and expectation of x2 square? Expectation of x1 square will be equal to what? Expectation of x2 square will be equal to what?
One.
Why? Why this one? So it is already given that expectation of x is equal to 0. So whenever expectation of x is equal to 0, we have the variance of x will be equal to expectation of x square. So this identity will hold. Okay, so because variance of x is defined as expectation of x square minus expectation of x the whole square. So when expectation of x is equal to 0, this term will cancel. So variance will be same as the second row moment. So that will be equal to 1 here. So this will become expectation of x1 square. X1 square, x2 square minus 1 into 1, that is equal to 1. So we can call this expectation of x1 square into x2 square as some k for a simplification. Expectation of x1 square, x2 square is equal to 1. Sorry, k. Just I am taking in this way. Okay. Then what about sigma, standard deviation of x1 square and standard deviation of x2 square? So for standard deviation of x1 square, so we can find the variance of x1 square. Variance of x1 square is equal to variance of x2 square is equal to. So this will be equal to expectation of x1 square the whole square. So that will be equal to expectation of x1 raised to 4 minus expectation of x1 square the whole square. The same will work here. Expectation of x1, x2 raised to 4 minus expectation of x2 square the whole square. So what will be the value of variance of x1 square and variance of x2 square? So for this, we need the fourth moment of the standard normal distribution. So either you can study, like memorize the results at least for the first few moments, or you can use the property of normal distribution to find out this fourth moment. So I will just explain how to easily. So in this way, actually, I am remembering this fourth moment. So we know the standard normal distribution is a what about the kurtosis of standard normal distribution? Coefficient of kurtosis. If we define that term beta 3 will be equal to mu4 divided by mu2 square. This is the definition of the coefficient of kurtosis. And using this definition, and this beta 3 will be value equal to 3 for a normal distribution. Okay, which is a mesochotic distribution. So beta 3 will be equal to 3. Okay. So you can remember this relation based on the standard normal distribution property. And when beta 3 equal to 3, you have mu4 divided by mu2. So this is the fourth central moment actually. So here expectation of x equal to 0, which means the central moment and the row moment will coincide. Okay. So mu4 will be equal to the expectation of x1 raised to 4 itself. Then mu2 will be the variance. Okay. So what about the value of mu4 then? Mu4 will be equal to mu2 square into 3. So that will be equal to, what is mu2 square? It is variance square. That is equal to 3. Right. So any doubts in this portion till now, like the results that I applied and the equations? Okay, I'm just continuing. So this variance of x1 square will be equal to expectation of x1 raised to 4. We got as mu4, that will be equal to expectation of x1 raised to 4. So that is equal to 3. The same will hold for x2 also, because x1 and x2. So if x1 and x2 are jointly bivariate distributed, jointly bivariate normal, then each of the individual components, that x1 will be following the corresponding normal distribution with its mean and variance. Then x2 will be also following the corresponding normal distribution with the mean of x2 and variance of x2. Okay. So we can find these values. Expected 3 minus this term will be 1 square. So that will be equal to 2. And here the same will happen too. Okay. So what about the standard deviation then? That will be equal to root 2. Okay. So we can then substitute in this relation. So in this relation, if you substitute, rho square will be equal to this thing. And this covariance we have already found out k minus 1. K is this actually. So rho square is equal to k minus 1 divided by root 2 into root 2. Standard deviation you have to take, this is variance. Okay. So that implies 2 times rho square. When you simplify, when cross multiply and simplify, you have to find this k. So root 2 into root 2 will give you 2. So 2 into rho square will give you k minus 1. So k will be equal to 2 rho square plus 1. So is it clear? So any doubt in any step, you can ask me or you can text in the chat box. If no, then we can proceed to the next question. Okay, so one more method is there that also I will explain. So this is actually based on this result. Okay, if XY follows bivariate, then the correlation between XY. So only in the bivariate normal case, this result, standard bivariate normal case, okay, means zero variance one case, this result will work. So one more method is there that also we can just follow, that I will give you. So 1 minute, let me just. Okay, so I will just mention that result here. So the result is so for a standard bivariate normal, that is x comma y following bivariate normal with mean zeros, variance 1 and correlation coefficient rho, then the recurrence relation between moments is mu r, that is the joined moments we are considering. Okay, so mu rs will be equal to which means expect, so mu rs is defined as that is equal to expectation of x raised to r and y raised to s. Okay, this is the definition of mu rs. Okay, so that will be equal to r plus s minus 1 into rho mu to the mu. Okay, this is again moment mu raised to r minus 1 s minus 1 plus r minus 1 into s minus 1 1 minus rho square mu r minus 2 s minus 2. That is, if you know the first two join moments, this r minus 1 s minus 1 and r minus 2 s minus 2, you can find out this rs join moment. Okay, this relation you can remember. Okay, so for this based on this, so here the mu r minus 1 s minus 1 will be defined as expectation of x raised to r minus 1 into y raised to s minus 1. So in the same way, mu r minus 2 s minus 2 is defined as expectation of x raised to r minus 2 into y raised to s minus 2. Okay, so for this result, you have mu 0, 0 will always equal to 1. So you can substitute and check mu 0, 0 will be always equal to 1. That is expectation of what it is, x to the power 0, y to the power 0. That is expectation of 1 only. So that is equal to 1. And if you consider mu 1 comma 1, that is equal to expectation of x to the power 1, y to the power 1, that is equal to what? This is equal to covariance. We already said this is equal to correlation in this case, because expectation of xy minus expectation of xy into expectation of expectation of x into expectation of y, that terms are 0. Standard deviations are 1. So this will be equal to the correlation itself, mu 1 1, that will be equal to expectation of xy, that is equal to the correlation rho. Okay, so if you consider mu 2 2, that will be equal to 1 plus rho square. You can just substitute in this formula for this r and s. So you take r equal to 2 and s equal to 2. So this is actually expectation of x square into y square. Okay. No, I think mu 2 2 will be equal to 1 plus 1 minute, let me just take it. So we were considering this thing right now, right? 𝜇22 will be equal to 1. 𝜇22 will be equal to 1 plus 2 rho square. So that was our question in this case. So this is a, you can just substitute in this relation and then you can just simplify. So this will be equal to 1 plus 2 rho square. So either you can remember these at least one, the first two symmetric. Symmetric means when R equal to S. Okay. So at least you can remember this. So this is a definition. Expression of x square into y square will be equal to 𝜇22. That you can substitute here. R is equal to 2 and S is equal to 1. So when R equal to 2 and S equal to 1, mu R minus 1 S minus 1 will give you 𝜇11. Then this R minus 2 S minus 2 will give you 𝜇00. So instead of this term, you can substitute rho, and instead of this, you can substitute 1. Then R equal to 2, S equal to 2. Just substitute and simplify, you will get it as 1 plus 2 rho square. So if you know this relation, this is actually a direct result. You don't have to apply the previous result. So the question was, in our case, the question was expectation of x1 square into expectation of x2 square. So here we got expectation of x square into y square since x, y were the random variables. Okay. So directly you can find the solution in this way. Or this is also extra benefits. Maybe sometimes there will be questions directly like if x, y follows this thing, then what is the correlation between x square and y square? So directly that questions appeared in many question papers that I have seen. So you can just remember this result as well. Okay. So any doubt in the second result that I said, you can ask me. Otherwise, we can move to the next question. So any doubt in the two methods that I explained? Okay, hope there is no doubts. So let's move to the next question. So here x1, x2, etc., x7 be IID random variables with the CDF and density small f. CDF means a cumulative distribution function. Then the density of the sample median. We have to find the density of the sample median. So how to find the density of sample median? So, or what is the idea of this question? Density of the sample median we have to find out. We have x1, x2, etc., x7. So what will be the sample median? That is the first question. Based on seven IID observations from a distribution with the CDF capital F and density small f, what will be the sample median? So median, you all know, the middlemost observation when you arrange the data in the ascending or descending order of magnitude. So for this case, we have 7 observations. So whenever the number of observations is odd, there will be a single value as median. If it is even, it depends on the middle two values. In discrete case, we take the average of the middle two. In continuous case, any value between the middle values can be the median. Okay. So here it is odd. So what will be the median of these 7 observations? That is the first question. And then once you know what is the median, then the question is what is its distribution. So what will be the median here? Any comments? So I already said the idea that you have to arrange these observations and then you have to take the middle one. So when you arrange these observations and take the middle one, what will be the median? So how will you arrange this? Here we apply the concept of order statistics. Okay. So based on the idea of order statistics, we can arrange this as x1 less than x2 less than x3. So total 7 observations are there. Based on the magnitude, we can order them. So x5, then x6 and x7. So it can be equal to also. So this is the idea for order statistics. So this is actually our arrangement in the increasing order. If I say x1 is the lowest possible value among these 7 and x7 is the highest possible value. So this is the ordering. So now the question is, what about the distribution of this order statistics? So I will give you the result to find out the density of the order statistics. So exactly, there are a lot of results related to order statistics. I can mention a few of them here so that you can apply the other results in other questions as well. Okay, so I will mention this. Let x1, x2, etc., xn be IID with the CDF, capital F, and density small f. Okay, so the arrangement will be like the order, the corresponding are given like x of 1 less than or equal to x of 2 less than or equal to etc. less than or equal to x of n. So x of n means the largest order statistic and x of 1 means the lowest, the minimum order statistic. Okay, so based on this definition, we can I will give you few results. So the first one is the distribution of the first order statistics, that is capital F of x1, the CDF. So this will be equal to 1 minus capital F of x the whole power n. Okay, so this is a CDF of the lowest order statistics. Okay, so this F is actually this CDF, this IID sample CDF. Then its density will be, you can just take the derivative to find out the density, and that will be equal to n into 1 minus capital F of x the whole raised to n minus 1 into small f of x. That small f will be the density here, the mentioned here. Okay, then about the largest order statistics, capital F of xn will be equal to capital F of x the whole raised to n, and its density will be equal to, when you take the derivative, n into capital F of x the whole raised to n minus 1 into this small f of x. This capital F of x is having the derivative small f of x. Okay, now the important result is the density of the rth order statistics. Okay, that is what we have to find out in this case. So in general, the density of the PDF of rth order statistic is small f of x r will be equal to, so the density will be like this, n factorial divided by n minus r factorial into r minus 1 factorial, then capital F of x raised to r minus 1, then 1 minus capital F of x raised to n minus r into small f of x. Okay, so this will be the, in general, this will be the PDF of rth order statistics. So r can take the values, from 1 to n. 1 to etc. up to n. Okay, so this you can remember using the beta integral. This is exactly the form of beta integral with, so in how we write the beta integral, 1 by beta pq. That when you simplify that gamma form, you will get this. This is actually the density form of beta with the parameters r and the n minus r plus 1. But the thing you have to notice here is, in beta integral, we will be defining the density of x following beta distribution, and so the x to the power r minus 1 and 1 minus x to the power n minus r, so or the q minus 1 term will come here. Instead of that x, we are having that capital F of x, okay, in the expression of beta density. And since we are using this capital F of x instead of x, we have to add the derivative of this capital F of x. That's why this small f of x, this is kind of a transformation thing. Okay, that is how this extra term will come in this beta form. So you can just remember this as the beta r n minus r minus form with the x is equal to capital F of x. Since x is equal to capital F of x, the small f of x term, the derivative term will also come in the expression. Okay. So this is the PDF of rth order statistic in general. This you have to remember. So here in this question, we have 7 observations, and we ordered it as x1 less than or equal to x2 less than or equal to etc. up to x7. So what will be the median from this arrangement? What is the median? For this arrangement, what will be the median? So here we have 7 values, x1 to x7. So median means the middlemost one. Okay, so the median will be equal to the 4th order statistics. This x4 will give you the median for this 7 observation, this 4th order statistics. So what will be its distribution in this expression? You have to the f of x is given as a capital F itself, and then density is given as small f itself. So you can just substitute the value of r as 4 here, and then you can find out the distribution of the median. So what will be the answer then in this case? This is the formula. You can substitute r as 4 and then simplify and let me know what is the density of the median that you are getting. So n is equal to 7 and r is equal to 4. So substitute these two in this expression and then simplify. So first thing what you can do is whenever you give the competitive exams, so the very first thing is you can just look at this terms, fx raised to. So our aim should be how to find the correct answer in a short time. Okay. So some options we can eliminate in between that we can do. So here capital F x to the power 3 is there, and 1 minus capital Fx to the power 3 is there, and f of x is there. So when you look into the options, then this option will not contain the whole the x part, and this will also not contain. There is no small f of x in this. So only these two terms will contain the exact form for this capital F of x, 1 minus capital F of x, and small f of x. Okay. So now the question is, what is the constant? So we can just find the constant and then find the value. We don't have to look about this A and D options here. So what is the value of this part? 7 factorial divided by, so that will be equal to 7 factorial. So we can take this as some say k. So this is 7 factorial by 3 factorial into 3 factorial into that k. So what is this value? You can simplify 3 factorial. So you all know the property of n factorial. N factorial will be equal to n into n minus 1 into n minus 2 up to 2 into 1. So in this way till 1. Okay. So 7 factorial by 3 factorial, this will become 7 factorial can be written as 7 into 6 into 5 into 4 into 3 factorial will come, that will cancel with 1 3 factorial the denominator. Then the other 3 factorial can be we can cancel with this 6 only. So this will become 140 into this k, that k is this part. So what will be the answer here? That will be option C. Okay. So you might know all these results, these distributions, especially the minimum order statistic and the maximum order, highest order statistics. Its density. It's so you have to remember only the CDF. From that you can easily follow the density and remember this density of rth order statistics. Don't by heart this formula itself. Just understand this as a beta. This form we already know the beta, that is familiar for us more. So in that, instead of x, we can use this f of x, and then don't forget to put this small f of x since we are using capital F of x instead of x. So that is all about this question. So any doubts you can, if you have, you can ask now. Otherwise, we can go to next question. So any doubt in any part, in any result that I mentioned, you can ask me. Okay, fine. So the next question, so actually these are all the ISI MStat entrance exam sample questions given in the ISI website. Okay. So till this question, I guess these are ISI questions and the rest are from the IIT JAM previous year question papers. So suppose X is a random sample of 4 observations. Suppose a random sample of 4 observations is drawn from the Poisson distribution with mean lambda, which is greater than 0. So that is the basic requirement for Poisson, that right parameter. Let X bar denote the sample mean. Then what is probability of X bar less than 1/2? This is a very easy question that we can do based on the basic properties of Poisson distribution and using its PMF. So how to find this probability? We have to find the probability of X bar less than 1/2. So it is already mentioned that the random sample of 4 observation. Okay. So X bar will be equal to what? X1 plus X2 plus X3 plus X4 divided by 4. So how to find the probability of X bar less than 1/2? So this will be equal to, so what is the idea? Can someone say what is the idea to solve this question? So what idea we can use to solve this question? Exactly, additive property we can use. So here X bar is equal to X1 plus X2. So the idea is whenever you see this question, you must be able to understand what result to apply. Okay, so for that you have to practice, you have to explore more questions, different applications of this result. So after practicing a lot, whenever you see a question, suddenly you will get the idea that what thing will be applicable here. So what result to apply here? Okay. So here you can apply the property of additive property of Poisson distribution. It's already given that is a random sample from Poisson with the same, with the same parameter lambda. So this is IID. So we can use the additive property here. So here X bar, so X1 plus X2 plus X3 plus X4 will be equal to 4 into X bar. Okay. So probability of X bar less than 1/2 will be equal to probability of this full. We can write X1 plus X2 plus X3 plus X4 divided by 4 is less than 1 divided by 2. That is equal to probability of X1 plus X2 plus X3 plus X4 is less than, this 4 you can take to right side. So 4 divided by 2 it will be, so this is less than 2. Okay, now the question is what is the distribution of X1 plus X2 plus X3 plus X4? So what is additive property of Poisson distribution? I will just mention that result here. Additive property of Poisson distribution. So exactly the result will be like if X1, X2, etc., Xn are independent. So I am just mentioning these as independent right now, not identical. Independent Poisson random variables with the parameters lambda 1, lambda 2, etc., lambda n, say. Then X1 plus X2 plus etc. plus Xn. will follow Poisson distribution with parameter lambda1 plus lambda2 plus etc. plus lambda n. Okay, so that is summation over xi follows Poisson distribution with the parameter summation over I lambda I. So this is the result for independent Poisson. That is, if x1 is having Poisson distribution with some parameter lambda1 and x2 is having Poisson distribution but some other parameter lambda2, and both the x1 and x2 should be independent. Okay, in this case the result will come like this. So but if they are IID, what happens? All the lambdas will be same. Okay, x1 will be following Poisson with lambda, but x2 will be following the Poisson with same lambda. In general, x and xi will be following Poisson with the same lambda. If they are IID, then the result will be IID, say with parameter lambda. Then summation xi will follows Poisson distribution with the parameter lambda plus lambda plus lambda till n times. So that will be n lambda. Okay. So this is the result that you have to apply in this case. So you can, I think you can find this probability based on this result. So here the distribution of x1 plus x2 plus x3 plus x4 will be x1 plus x2 plus x3 plus x4. Here it is a case of IID with parameter lambda. So this will be following Poisson distribution with the parameter 4 lambda. And again, what is the density of if x follows Poisson distribution with the parameter lambda, where lambda greater than 0, then P of x will be equal to, what is the PMF? E raised to minus lambda, lambda raised to x divided by x factorial, where x varies from 0, 1 to etc. Okay, so we can just find out this density here. Say Z is equal to this x1 plus x2 plus x3 plus x4. Then what will be probability of Z? E to the power minus 4 lambda, then 4 lambda the whole raised to Z divided by Z factorial. So here you have to find the probability of Z less than 2. So here Z can take values 0, 1, 2 up to like discrete values it can take, non-negative integer values. Okay. So what is probability of Z less than 2 based on this range? That will be equal to, so here this is a PMF. Okay. So at each point there is a mass. So less than 2, if there is equal to, then that will include the probability of Z is equal to 2 as well. Here it is less than 2. So it will include the probabilities of Z is equal to 0 and Z is equal to 1 only. So this is equal to probability of Z is equal to 0 plus probability of Z is equal to 1. So you can just substitute the value of Z as 0 in this PMF to get this P of Z is equal to 0, and Z is equal to 1 in this PMF to get the value of P of Z is equal to 1. And then let me know what is the solution that you are getting from this line. I am just writing this line. So that is equal to, what is the probability? E to the power minus 4 lambda. Then 4 lambda raised to 0, that will give you 1, then by 0 factorial. So again, remember this thing, 0 factorial will be always equal to 1. So this is e raised to minus 4 lambda plus option B. Okay, very good. So e raised to minus 4 lambda into 4 lambda raised to 1 divided by 1 factorial. You don't have to add that. Okay. We can just simplify and see the answer. So here the answer will become, okay, so e raised to minus 4 lambda is common that you can take outside. So 1 plus 4 lambda. Okay, so this will be the solution. So option B will give you the correct answer. So any doubt in this question in any part? So these are actually basic applications, but so once you solve a question in this form, whenever you see another question, you can easily get the idea that this result should apply here. In this way, you have to convert it into the sum, and then you have to find the distribution of the sum based on the independence property, and then you have to evaluate the probability. So this is the only idea. So I hope this is also clear to you all. So let's move to the next question. So in case anyone of you have any doubt, you can just ask me. Okay, so you can just type in the chat box also. That is also fine. So the next question is, let sequence xn be a sequence of independent and so that is IID random variables with the probability density function f of x is equal to 1 if 0 less than x less than 1 and equal to 0 otherwise. So can someone tell me what is this distribution? Based on this PMF, you should be able to identify the distribution. So what distribution this is? F of x equal to 1. Based on this range, you can easily identify, right? 0 less than x less than 1 and equal to 0 otherwise. Yes, it is uniform 0, 1 random variable. So that is the first thing you should identify when you read this question. Okay. Now we have to find the value of this limit n tends to infinity, probability of minus 1 by n summation I equal to 1 to n log xi less than or equal to 1 plus root n. So while looking into this question for the first time, we may feel how to solve this question, how to find this answer since log is there. This is actually very simple questions that we can solve in a few seconds. Okay. So for the very first thing that you should know is there is a result. The result means you can find, you can just derive this and then you can see the relation. If, wait 1 minute. If x follows uniform, x follows uniform 0, 1. Okay. Then minus log x follows. So can someone tell me what will be the distribution of minus log x in this case? This is a very good result that you can apply to lot of problems in the competitive exams in statistics. Okay, especially related to the CSIR questions. You can find so many questions that applies this result. So if x follows uniform 0, 1, you can just apply the property of Jacobian to find the distribution of this minus log x. You can take y is equal to minus, just a transformation, and then you just find out this distribution in detail. Okay, so I will just mention the result here. So minus log x will be following exponential distribution with parameter 1. Okay, so just find out the distribution using the Jacobian property, and then you just see the result. Okay, so then here you can see there is a thing like limit n tends to infinity. So whenever there is a question, there is a term like limit n tends to infinity, you have to apply the large sample theorem. Okay, the central limit theorem will work there. So you know what is the central limit theorem? If xi's are IID random variables with the mean, finite mean, mu and variance sigma square, then central limit theorem says x bar minus mu divided by sigma will be following normal distribution with 0, 1. So whenever there is n tends to infinity mentioned, you can just apply the property of central limit theorem. Okay, so if I call this minus log x is equal to minus log xi is equal to yi, so how this expression will become? That is minus 1 divided by n summation I is equal to 1 to n log xi. This will be equal to minus log xi will be equal to yi. Okay, so this will be equal to 1 by n summation I equal to 1 to n ya. So this will be equal to y bar actually. So you have to find the mean of y bar and the variance of y bar. Then just substitute the subtract the mean from here and divide by variance so that you can do the same here also. That will be following the okay, this term will be following, this y bar will be following the standard normal distribution. So from the standard normal, this property, this z less than or equal to something, you can find this phi of, say it is c, then phi of c will give you the answer. So this is the idea. So you can try this question, that find out the mean of y bar, expectation of y bar, and then variance of y bar. What is expectation of y bar and what is variance of y bar? So if x follows some distribution with mean mu and variance sigma square, then x bar will be having asymptotic distribution will be that will be same with mu and sigma square divided by x. So this mu will come from the mean of x and the sigma square will be coming from the variance of x. Okay, so here instead of x we have yi. Okay, yi means minus log xi, and that is having distribution exponential 1. So what will be expectation of yi? And what will be variance of yi? Again, whenever you solve questions for while practicing, So whenever there is a question from exponential distribution, then you have to apply the mean, variance, everything. You just write down the formula of mean. So just write down if x follows exponential distribution with parameter lambda, then f of x will be equal to lambda into e to the power minus lambda x. Then expectation of x will be equal to lambda 1 by lambda. Variance of x will be equal to 1 by lambda square. Even though you don't have to apply this expectation of x and variance of x, but when you solve a question from exponential distribution, just write down the PDF, just write down the expectation, whatever basic results you know from this distribution. Okay, so when you do this for many questions, automatically this will feed in your mind. So you don't have to by heart the expectations and variance and all. So whenever you do a problem from some distribution, just write down the PDF, write down the important properties. Say for exponential, there is the lack of memory properties there. So just write down the expression for that. Just write down the expression for expectation, variance, MGF. So when you solve 10, 12, 15 questions from the exponential distributions, and when you do these things, automatically this will feed in your mind. Okay, so you don't have to by heart these things at the end. So here expectation of YI will be equal to 1 and variance will be equal to 1. So expectation of Y bar will give you 1, variance will give you 1 divided by n. Okay, so the required probability is, say if I call this as some P, then P will be equal to limit n tends to infinity. So limit n tends to infinity means we are applying the central limit theorem property. So you don't have to write that limit things again, since using the central limit that n tends to infinity condition, we are finding this mean and this variance here. Okay, so this will be equal to probability of, so this is Y bar. Okay, so probability of Y bar minus expectation of Y bar divided by sigma, standard deviation of Y bar. That is less than or equal to, so you have to subtract the same expectation of Y bar on the right side. You have to divide the same sigma Y bar in the right side. So that will be 1 plus 1 by root n is already there. Subtracting this expectation of Y bar will give you -1, and dividing with the standard deviation will give you, this is variance, so standard deviation will give you 1 by root n. Okay, so this is the, so here this is actually a standard normal, that is normal 0, 1 variate. So this will become probability of a normal variate less than or equal to, this will cancel, 1 minus 1 will get 0 cancel. So this will be 1. So what is this based on the CDF? So phi is already the CDF. So you can see in this question, phi is not mentioned as what? We already know this phi term is used for the CDF of standard normal, or this will be mentioned in the beginning of the question paper. Okay, whatever notations used in the questions will be mentioned in the beginning, that you can see. So this will be equal to phi of 1. Okay, so phi of x we define this as probability of z less than or equal to small x, where z is following normal 0, 1. So that is all about this question. So one thing that you should know is the property of the central. So when there is a time like limit n tends to infinity, you should think about the central limit theorem. Then central limit theorem will give you this this thing, that is the mean minus its expectation divided by its standard deviation will tends to standard normal. And then one results you should know here is x follows uniform. If x follows uniform 0, 1, then minus log x will be following exponential distribution with the parameter 1. So this relation you have to remember. So you can just verify this relation using the Jacobian transformation, and then you can see this result, how it will come. So any doubt in this question, in any step that I mentioned, we can ask. Otherwise, we can move to the next question. I can ask the doubt, Mufida. Okay, I think it's my mistake. So any doubt, is it clear? Okay, fine. So you will be going to next question. Let x be, these are actually IIT JAM previous year question papers. Okay, so whenever you prepare for the exam, so if you're preparing for the JAM exam, then try to solve some question papers that is having low level of JAM syllabus or JAM pattern. Then after practicing that questions, then only you should come to this question paper. Okay, so in a sudden, if you start solving, you may feel disappointed. So when you don't, when you are not able to solve some questions initially. Okay, so so for this question, let x be a uniform 0, 1 random variable, and let y is equal to x square. If rho is the correlation coefficient between the random variables x and y, then 48 into rho square is equal to. So this is exactly a direct question. So you have to find the correlation coefficient between x and y first. That will give you rho, and then you have to find the value of 48 into rho square. So you can, all of you can try how to solve this. So rho is equal to correlation between x comma y. Okay. So how to expand the correlation between x comma y? That is equal to covariance between x comma y divided by standard deviation of x into standard deviation of y. Now what is covariance between x comma y? It is equal to expectation of xy minus expectation of x into expectation of y. Again, we have y is equal to x square. So expectation of x into y will give you expectation of x into y equal to y square, sorry, x square. So x square minus expectation of x into expectation of x square. So this will give you expectation of x cube minus expectation of x into expectation of x square. Okay, this is all about the covariance type. Then variance of x, you can write it as expectation of x square minus expectation of x the whole square. Then variance of y will give you expectation of y square minus expectation of y the whole square. Okay, so this will be, we don't have any idea about the random variable y, means the distribution of y, like we already have the relation y equal to x square. So wherever there is y, you can just substitute y as x square and then simplify. So this will be equal to expectation of y is equal to x square. So y square will be equal to x square the whole square, that is x to the power 4 minus expectation of x square the whole square. So the question is all about finding the third moment, the second moment, the fourth moment of this uniform 0, 1 random variable. So you can find out this value. So let me know what is the value of expectation of x raised to 4, what is the value of expectation of x cube, what is the value of expectation of x square, then what is the value of expectation of x. So only these 4 terms are needed. Then we can just substitute and simplify to get this row. Then you can find 48 into rho square. Okay, so one more thing I would like to add here. So here the distribution is uniform 0, 1. So as I told you, whenever you have a problem with uniform distribution, so try to write down the formula of general uniform distribution. Like if x follows uniform distribution over the range 0 a b, then its PMF is, so its PDF is f of x will be equal to 1 divided by b minus a. Okay, where a less than or equal to x less than or equal to b and equal to 0, otherwise that is there. Then expectation of x will be equal to b plus a divided by 2, and variance of x will be equal to b minus a the whole square divided by 12. So CDF also you can note x minus a divided by b minus a into that time also, like, that is easy to follow from the definition actually, because this is actually a constant, so there is no problem with the integration center. So what will be expectation of x raised to 4 then? That will be equal to integral over x raised to 4 into f of x into dx. So here x is following uniform 0, 1. So f of x will be equal to 1 over the range is 0 to 1 here. Okay, that will be equal to integral 0 to 1 x raised to 4 dx. So that is equal to, what will be the value? X raised to 5 divided by 5. Then you have to apply the limit from 0 to 1. This will be equal to 1 divided by 5. And there is a relation that you can remember. You don't have to write this integral, even though the integral is easy. Just writing the one line will also take you some time, take you some of your time, right? So you can just remember these things. So whenever you find the expectation here, what is actually happening. For I am talking about uniform 0, 1 random variable. Okay. So whenever you find the moments, row moments, so what will happen? This f of x will be equal to 1. So whatever be the value of this r, in general, if I say expectation of x to the power r, that will give you 1 divided by r plus n as the value. If x is following uniform 0, 1. I hope you understood this concept, that you have to substitute x. How this will come? This will be integral 0 to 1 x raised to r into fx dx. So that is equal to integral 0 to 1 x raised to r into 1 into dx. That will give you integral 0 to 1. So you can find out this integral like x raised to r plus 1 by r plus 1 from 0 to 1. That will give you 1 by r plus 1. So when you find the row moment, in general, the rth row moment, expectation of x to the power r will give you 1 divided by that power plus 1, 1 by r plus 1. So what will be expectation of x cube then? What will be expectation of x square then? Again, what will be expectation of x then? What is
1 by
expectation of
4.
x cube? 1 by 4, 1 divided by 3, and here it will be 1 divided by 2. Okay, so you can just substitute these values: 1 by 5, 1 by 4, 1 by 3, 1 by 2. Just remember this idea. Okay, so if you don't think about this idea, what you are going to do? You will like just write x raised to 4 into this thing. You don't think about it, what you are doing. Okay, so whenever you do the steps, you just think what you are doing, that idea. So in general, how we can generalize this idea. So that in that way, you should practice the question. So question the question. Okay, whenever you do some questions and you find some results, you ask again you question the question, that what if this will be like this, what if this will be like that. In that way you should learn. Okay, for every competitive exam, if you learn in that way, you can find more idea, you can unlock more concepts. So I'm just sharing my experiences when I was preparing for the exams in between. Okay, so you can just substitute these values. I hope you know this. So you can just substitute expectation of x square as 1 divided by 3 and expectation of x is 1 by 2 here, then simplify. And thus here it will be expectation of x raised to 4 minus this thing. Then here you have the covariance term like expectation of x cube minus expectation of x into expectation of x square. So just substitute all these values and let me know what is the value of rho. I am not going to simplify all these things. You can try your own and let me know what is the value of rho. So again, one thing, you practice more problems whenever there is a complicated integral or complicated simplification. You don't leave that question and skip that question. Just practice, because in the exam hall, you have to do the questions by your own. Okay. So, and one more thing, if you are not good with the virtual calculator, so when you practice the question, don't use calculator for simplification. Just do manual work. That will also help you to save a lot of time in the exam hall. Okay. So, and let me know what will be the value of rho in this question. Can just give you the final covariance of x, y, 10. This will give you covariance when you substitute these results. The covariance between x comma y will be equal to, so anyone got the answer? So I am expecting that you are all doing these calculations. So kindly let me know once you get the answer, the covariance between x comma y, then variance of x and variance of y. So what about covariance between x and y? 3 root 50 divided by 8. So you are saying the final answer or so covariance between x and y, what is the answer? This is actually just 1 by 4 minus 1 by 2 into 1 by 3, right? 1 by 4 minus 1 by 2 into 1 by 3. Okay, final. Haha, okay, fine. So this will give you 1 divided by 12. Covariance between x and y will give you 1 divided by 12. So what about variance of x? This will be 1 by 3 minus 1 by 2 the whole square. That will give you, very good, 1 divided by 12. What about variance of y? This will give you what is variance of y? Okay, 4 divided by 45. Very good. So we can substitute and then we can solve for this covariance of x comma y by sigma x sigma y as 1 divided by 12 divided by square root of 1 by 12 into square root of 4 divided by 45. So don't be afraid of the square terms. The question is already about 48 into rho square. So since even though there is root, when you take rho square, the root will get cancelled. So 1 by 12 divided by 1 by 12 into 4 divided by 45 will give you rho square. So you can just simplify these two terms will get cancelled and this will be 45 divided by 45 divided by 4. Okay. So then 48 into rho square will give you 48 into 44 divided, 45. Into 45 divided by 4. So you can simplify this 48 and 4. That will give you what? 12, right? 12 into 45. So what is the final? Okay, 1 minute. Did I made any mistake here? Okay, sorry. So in the numerator, that will happen. Like this term will give you a big value, 12 into 45. So the options are all like 48, 45. So you should understand that some mistake has happened. Okay, just go back and look at the mistake here. So here it is 1 by 2, 12, the whole square will be there. Since the numerator was already 1 by 12, so when you take the square, so one more 1 by 12 will be there. So there will be a by 12 in the denominator. So that will again get cancelled and the answer will be 45. Okay, fine. So most of the time I was observing that whenever there is a question like find some constant, they say rho, some alpha, some beta, and then multiply it with some constant and give and find the value. So most of the time the answer, the question will be like cancelling the common terms, and so we don't need that much simplification at the end. So there you can find many questions in the same format. Like at the end, you can say the numerator and denominator will be containing the same factors, and that will easily cancel out, and that will give you a simplified value in very less time. So I hope we applied a lot of things here. Okay, so the idea, everything like the basic idea only, but you have to apply in different ways to different questions. That is the only thing. So the competitive exams are actually about how you are applying the theory that you learned. Okay, it is not about how much theory you know. It is all about how you formulate the question, how you apply the result to the questions. So how you it also measures your calculation kind of ability. Like you should be able to calculate without mistakes. That also you have to take care about. So by practicing more and more questions, eventually all this will get cleared. Okay. So I hope there is no doubt in this question. And then we can move to the next question. And sir, what about the time? So let me know when should I stop. So we will discuss this question. This is a very easy question. Let x be a random variable with the probability density function f of x equal to 1 by 2 e to the power minus mod x. So what distribution it is? This distribution. This is actually the standard Laplace distribution, or we can say double exponential distribution. Okay, with the parameters as in the standard form, or a double exponential distribution. So just make a look at this distribution. So in the JAM exam and the GATE exam, this distribution is actually very important. This double exponential or the standard Laplace distribution. Okay, so standard Laplace distribution. This distribution will be these points you should remember. Okay, this will be symmetric about 0. Okay, this distribution will be symmetric about 0. Then the question is, which of the following statements is false? So that is again another trap in competitive exam. Most of the times the questions will be like, so whenever we see some answer as correct, we just note or we just mark that answer. So we don't read the question properly. Like most of the time the question will be to find out the false statement. Okay, false option. So that also you should be care about while solving the questions. So you can see that how we find the expression of a function g of x. So expectation of g of x will be equal to integral over x g of x into f of x into dx. So I already told you this distribution is symmetric about 0. So we can split this integral as integral from minus infinity to 0 g of x into f of x into dx plus integral 0 to infinity g of x into f of x into dx. Okay, so whenever g is an odd function, okay, when g is odd function, so you know the property of odd function. So g of x will be equal to minus g of x. This will give you g of x as an odd function, and then g of x is equal to g of x is g of minus x equal to, okay, g of minus x equal to minus of g of x. That will give you the odd function. When g of x is equal to g of minus x, this will define an even function. So whenever g is odd, that implies expectation of g of x will be equal to 0 when x is symmetric about 0. Okay, whenever a random variable x is symmetric about 0 and the function that you are evaluating the expectation that is odd, then the expectation will give you 0. And only if it is even, then only we can find the some finite value for that expectation. So based on this simple idea, you can tell me which among these options will be false. So you can, what you have to do is take g of x as this x into mod x first, then check whether this function is even or odd. If it is odd, then this will be equal to 0. Then check x into mod x square, then check this term and check this term. So which function will give you an even function, and corresponding to that, the expectation will not be equal to 0. Since all the expectations are given as 0 in the options, you can find one function that is even and that will not give you 0. So that will be the answer for this question, that false option. So just check and let me know which will give you the even function among these 4 options. So for the first option, you have x into mod x, okay? So you all try yourself, like just basic idea. So in the first case, you have g of x is equal to x into mod x. So what is g of minus x? You have to just substitute minus x instead of x. That will be equal to minus x into mod of minus x. That will give you minus of x into mod x. That is equal to minus of g of x. So this g of x will be an odd function. So its expression will be equal to 0. So this statement is true. Okay, this statement is true. Then the second case, you can verify your own. No need to look for my steps. Okay, x into mod x square if you take. Okay. So g of minus x will be equal to minus x into mod minus x the whole square. That will be equal to minus x into mod x square. That is again equal to g of minus x. Sorry, minus g of x. Minus g of x. So that is again O. So did anyone got the answer for this question? Which one is even? Option C is even. Okay, let's see. And g of x is equal to mod x sine x by mod x. So that implies g of minus x will be equal to mod of minus x sine of minus x by mod minus x. So you know this result, sine of minus x will give you minus sine x. Okay, you can apply that to here. So sine of minus x will be equal to minus sine x. Okay, so when you apply that result here, mod, this will become mod x into sine of, this is minus, then the denominator that will be a positive. So this will become minus of mod x into sine x by mod x. So this is again minus of g of x. So that will give you an odd function. That here also the g of x will be odd. So how the option C will become even? So now I hope it is clear now. Maybe you made some mistake. Is it clear now? The third option will give you an odd function. So its expectation will be equal to 0 and this statement will be true. Is it clear? Okay. So since the three options are actually fine, like correct, the answer for this question is, that is a false statement will be of course D. And how it is D? So mod x into what we have in the fourth option, it is mod x into, so we take g of x equal to mod x into, that is sine square of x by mod x, that is sine x by mod x the whole square. So what is g of minus x in this case? That is equal to minus mod x into sine of minus x divided by mod minus x. This will give you the whole square. Okay, so that will be equal to mod x into, even though this will be minus sine x divided by mod x, you are taking the square. So the negative sign will get cancelled. So this will turns out to be sine of x divided by mod x the whole square itself. That will be equal to g of x. So this will give you g of x equal to g of minus x. That implies g of x is an even function. So this is just the application of this odd and even property. So one thing you should remember this. Remember is this. Okay, when the distribution is symmetric about 0, then when you evaluate the expectation or integral for some odd function, then that integral will be equal to 0. Okay. So any doubt in this question, in any part? Is this question clear? Okay, fine. Sir, shall I continue?
Yeah, I think we can go for five more minutes.
Okay. So question number 9, let sequence xn be a sequence of independent and identically distributed normal zero and random variables. Then probability. This is again the application of the, so actually these two questions are from the same question paper. Okay. So once you know the theory from one question, then you can apply that thing to the other questions. So that this question came in the same question paper and the same pattern will repeat it after year, in every year. Okay. So the idea that we are applying is same, with difference only in the distribution, with only in the these constants that is used. Okay. So you can try this question. Let's sequence x and be a sequence of IID n0 normal 0 1. The limit n. So you can again apply the theory of central limit theorem here. Summation I is equal to 1 to n probability of x raised to 4 minus 3n by square root of 3n 32n less than or equal to root 6. So what to do? So you have to find the, so you have to convert this into a standard normal. So x is actually a standard normal random variate. Then, so how to do this? So you can just take. So I'm just taking here x follows normal 0, 1. Okay, so I'm just taking this sum as sum is set, say, and we are just looking, most of the cases, this subtracted time will be the expectation of this EZ. So here it is sum. So in the previous case, we took it as x bar. In that case, you have to subtract the mean of x bar and divide the standard deviation of x bar. Here, if you are taking this sum, then you have to subtract the mean of this sum and the standard deviation of this sum. Okay, so if x follows normal 0, 1, what is expectation of x raised to 4? So we already we have seen this based on the kurtosis property of normal distribution previously, that beta 2 is equal to 3, that we know, and then beta 3 we define at mu 4 by mu 2 square. Since it is standard normal, the odd and row and central moments will coincide. So mu 4, the fourth central moment will be equal to the fourth row moment. We already find this value as 3. Okay, so expectation of x raised to 4 will be equal to 3. So then if I take Z is equal to summation over I, xi raised to 4. What is expectation of Z? I varies from 1 to n. So what is expectation of Z then? Very good, 3n. And what about variance of Z? Before that we have to find variance of x raised to 4. So what is variance of x raised to 4? Then we can just find the sum. Okay, since their IID, the covariance term will get cancelled, so we can just take the sum of variances of different xi's. So variance of xi raised to 4. So how we will write this? Or in general, if we write variance of x raised to 4. So what this will be? Based on the variance expression, variance of x is equal to expectation of x square minus expectation of x the whole square. We can write this as expectation of xi raised to 4 the whole square. So that will be equal to xi raised to 8 minus expectation of xi raised to 4 the whole square. So now this is a task, xi raised to 8. How to find out this expectation of xi raised to 8? So till this fourth moment, we can generally find out using the already known, well-known properties of the distribution. And for these moments, just you have to find the recurrence relation. If I say in general there is a relation in normal distribution, I think you all might know that relation. That relation I will just mention here. So if you don't remember it, then just recall and then note it down. Okay. So if x follows normal distribution with 0, 1, then you all know that all the odd moments will be equal to 0. So why that will happen? When you find odd moment, it will be some x to the power. Odd moment means expectation of x to the power some odd value, some 2r plus 1. So normal distribution is again symmetric about 0. So I already told you, when you find the expectation of an odd function for a distribution which is symmetric about 0, then the value will be equal to 0. That is how the odd moments of normal distribution will become 0. So then expectation of x to the power 2n minus 1. Either you can write it as 2n plus 1. That will in general represent an odd function, odd moment, or you can write it as 2n minus 1. That is also representing an odd value. Okay. So this will be equal to 0. And for the even moments, x to the power 2n, we can write in general. So that will be equal to, the relation is 1 into 3 into 5 into up to 2n minus 1. Okay, this is the relation. So you should be aware of this result to find these expectations actually. Okay. So expectation of x raised to 8. So here 2n equal to 8. Okay, that also you should be care about. 2n will be equal to 8. That will give you n equal to 4. So what you have to do is, what is 2n minus 1 then? 2n minus 1 will be equal to 7. So what you have to do is, you have to just multiply all the odd numbers from beginning from 1 till 2n minus 1 to get the corresponding expectation. So in that way, what will be the expectation of x raised to 8 then? For this question, what is the expectation of xi raised to 8. What will be the expression of xi raised to 8? Okay, fine. 105. So how it will become? This will be 1 into 3 into, I already told you this is 7. So we can go till 7, 4, 5 into 7. So that will give you 105. Okay, then expectation of xi raised to 4 is already 3, we know. So this term will become 105 minus 3 square. Okay. So what is the answer? Variance of xi raised to 4 will give you 96. Okay. So I think till this is fine, variance of xi raised to 4. Now we have to find the variance of z, and z we defined as summation over y raised to 4. Sorry, xi raised to 4. So what will be variance of z then? Variance of z will be equal to summation over I is equal to 1 to n variance of xi raised to 4. Since xi's are IID, the covariance term will get cancelled. So there is no covariance term in between. So we can just write this as sum of variances of this xi's. Also they are IID, so variance of xi raised to 4 will be equal to same for all I. So we already got the variance as 96. So this will give you 96n. Okay. So then we can just come back to this expression, that is z minus expectation of z divided by sigma of z. This is what we are trying to find. So that is equal to z minus, z means the summation. Okay, z minus. Okay, so there is one more thing. I am just that is like z means this summation xi raised to 4. Okay, so don't get confused with the standard normal z. Okay, so z minus 3n divided by what will be the standard deviation in this case? Square root of 96 into n. So here in this question we have summation I equal to 1 to n xi raised to 4, that we called as z minus 3n divided by square root of 32 into n only. But if you convert this into I am just calling this z star as the corresponding standard normal variable. Okay, so z star the star will be following normal 0 1. Okay, so so for that you actually need square root of 96 into n, but we only have square root of 32 into n. So what to do? Just do a multiplication by a constant to make this into 96, then do the same in the right side also. So what time should multiply here to make these square roots? The idea is if the denominator was square root of 96 into n, we can apply this standard normal result and then we can find the probability. But here in this question, this is actually the central limit theorem application. But in the question, it is only 32 into n. So what we can do, n is, sorry, square root of 32 into n. So already root n is there. Here also root n is there. One root 96 we need, but only root 32 we have. So what to do? How to make 32 into 96? 32 into 3 will give you 96. Okay. So here you need root 96. You can just multiply by root, the denominator, you can just multiply by square root of 3. So that will, this probability will become probability of z minus 3n divided by square root of 32n less than or equal to root 6. That will be equal to probability of. So we are applying the central limit theorem already. So that's why I'm not writing the limit n tends to infinity from here. Okay. So z minus 3n divided by this square root 3 we will multiply. So that will come in the right side also. So square root 3 will be here, and here it is square root of 96 into n now. So that is equal to again probability of z star. This was our standard normal variate from here. Okay. Z star less than or equal to what is root 6 by root 2? That will be root 2. So this is again the CDF of a standard normal variate. that is probability of Z star less than or equal to root 2, that will give you the probability as phi of root. So the correct answer will be option B. So I hope this question is the solution that I have mentioned, that I explained is clear to all. So just remember these results. Okay, the recurrence relation or the relation for finding the, or the equation for finding the even row moments and center moments will coincide in standard normal. So this relation you should remember. And then variance property, variance expressions, and all these things we already know by applying to various questions. So, and also remember the central limit theorem property. Whenever there is a question like limit intensity probability or something less than or equal to, always remember the idea of applying the central limit theorem and converting that into the standard normal variable case. Okay.
Okay.
So any doubt you can ask me. Otherwise, I think we can stop. Is it clear to all?
Okay.
Okay.
Thank you. Yeah. Thank you, Elizabeth. Thank you for this nice session. Your presentation is really nice, and the explanations are very simple and nice. So thank you, Elizabeth. Thank you for this nice session once again, and wish you all success in your academic career.
Thank you, sir.
You have done, yeah, you have done the job very good. Your presentation skills are really commendable. I'm sure that you will become a good teacher. All the very best. Thank you.
Thank you, sir. Thank you, sir.
Okay, let us wind up here. Bye.
So thank you all the participants for the cooperation. Thank you.